I wanted to make this video right here because I'm doing something special, but it's completely against mainstream, and I know most people won't understand it, but hopefully you do. I got the rod down the center of my Tesla coil. It is simply going to my Rodin coil. And I have the mysterious can here. It's not hard. It's just a can with tape on it, electrical tape, a couple layers, and then I have a winding on the bottom, and then a winding up above it. And that's just 14 gauge copper and some shielding, so basically wall wire. And as you can see, one of them is connected to the can, the other one's connected to just the wire. They're both going to a bridge rectifier right here, and then into my capacitor. Now, I have a motor here set up, but I don't think it's going to run. It's been sitting outside for a very long time. So, all I want to show you is how the energy builds. And it takes a little while because that bridge rectifier is not made for this. But let's go ahead and turn everything on. And yeah, I put some fans over here. I was doing another experiment with this, and I needed to cool it off some more, so I just threw up some fans over there. Anyway, okay, everything's fired up. Bring that up to 11 volts. Bring it up to about 17 volts so you can see it. There you go. Now, here's all I'm going to do. I'm just going to show you the numbers that come out of this. Sorry, let me get the camera set. And we are set on volts. That's 5.2, 5.5 so far. Bring it down to amps. 1.26. That's not bad so far. Let's give it a few more minutes. This may take some time, but we're going to let it go. Again, the full bridge rectifier should probably be some better, faster switching diodes, but that's okay. We do with what we have here until we get the right stuff. So the goal here isn't so much how fast it does it. I just want to get usable voltage and amps out of this thing. I don't know the best way to show this. Every time I get over here, it looks like it sucks. So we're still on amps. There you go. 2.24, 2.30. Now, a lot of people tell me you cannot get usable amps out of this. Well, in that capacitor, it'll stay in there. Let's check the voltage. Turn on a little light. There you go, that's respectable. 16 volts. Not bad. We'll give it a little bit more time to charge up. Again, we're 17.5 volts going into our Tesla coil. And circuit's running good. No issue there. So just give it a few more minutes to charge up. So let's look at our amps again. Turn on a little light. 3.4445. So the amps are growing. Go back to the volts. $21 volts. So right now we have usable energy. Now again, like I said before, it's taking its time to get there. By no means is it going fast. But considering what we're getting out of it, I'm not going to say that's a bad thing right now. We can fix the speed thing, that's not a problem. The problem we usually get is it going to be usable voltage? So, increase the speed, we should be able to do okay. So, we're about, what, 5.5 minutes in, so in about 6 minutes we'll check it again. And like I said, the only thing I'm looking for here, guys, is I want to make sure we have usable volts and amps. Now, I don't expect any motor to run or anything right now, and I probably don't have it set up the right way for that. Again, we'll just take a look at the setup real quick. There's my cap. There's my can right there. Again, why is it working with this? I'm inverting fields, guys. I'm taking a one-wire energy with the dielectric on the inside and making it to the dielectric on the outside. It's that simple. I'm taking a wire wrapped around it right there to make amps out of it. And it's a simple soda can. But it's knowing what you're doing, not what the parts actually look like. There's the rodent coil, again, connected to the one-wire energy at the bottom of my Tesla coil with the rod going down the center. So, go back and look at it again. And we are still in volts. Sorry, I'm trying to get that wire out of the way. 28 volts. We are in amps now. 5.20. Now they're all in DC. There's no question about that. They're not AC, they're in DC. Again, the bridge rectifier right there puts them in DC. And, you know, we're just taking radiant energy and we're switching it back to DC voltage. So we're at 7 minutes. Like I said, this is, take some time. We'll check it again in a few more minutes. All I want to see is if it gets past, you know, maybe up to 6 amps. 17.5 volts. So we're definitely not in over unity territory, that's for sure. But we are getting some usable numbers here. Let's see, we're still in amps. 5.83 amps, we're almost to 6 amps. We're back to volts. 33 volts. Not bad at all. So we're swapping the energy coming out of the rod down the Tesla coil. That's radiant energy. It's negative energy, however you want to call it, cold energy. I'm using a soda can to switch it. What is the big understanding of this soda can? Because you're going to probably want to know this. That wire right there on that top. So if I just take these multimeter wires and I take one and I go like this and I loop it. Now I'm just going to counter wind it to the bottom winding, the opposite of that, and just take it like that and wrap it around and tape it. It's as simple as it gets. But it'll allow you to pull current out of something that's just voltage. And this goes back to an understanding. If you take a ferrite core and you put windings on one side of, you know, very high gauge wire, then you put very low gauge wire, which basically means you're going from very thin wire to very thick wire. It'll pull more amps out. People use it to make welders online. You can look it up. It's just as easy as that. We're simply using some smarts and understanding to get this. We understand conversion. That can is flipping the field so I get voltage and amps out of it, not just voltage. So we'll check it again. We are in voltage right now. .39 volts. You see it climbs. Turn the light back on. 7.12 amps. That's not bad at all. Now, before it gets any bigger, I'm going to discharge this capacitor. So, let's take a look at that. You say, well, is it in it? Let me turn everything off. Don't need anything going back to a circuit. Don't try this at home. Yeah, get all of it out. And there you go. Usable voltage. Can we make it better? Absolutely. Do we have a good start? Yes, we do. You decide what you think it is. I don't think it's over unity yet. We're not getting the voltage in there and amperage in there faster. We are getting a usable amount. That's a good thing. So, I didn't even try the motor, guys. I didn't even want to bother. Look, it's not about that. It's just simply about, can we get the amperage up? And the answer is absolutely yes. That is a very simple winding that goes on a soda can. That's all it took to get there. You decide what it is. I hope everybody has a great day. Thank you.